In this video, I'll show you how to use Excel to solve some of the problems in Chapter 8. So here is a problem from our lecture. The distribution of hours worked by students at Maricosta College is normally distributed. If the population standard deviation is 5 hours, using a 90% confidence level, what is the margin of error if a random sample of 64 students has a mean equal to 23 hours? So here on our left is the formula to find the margin of error when the population standard deviation is known. So here we have equals confidence.norm, and in parentheses, we'll type in our alpha, the standard deviation, and the sample size. Note that the alpha is just 1 minus our confidence level. So for instance, if I wanted to use this formula to find the margin of error in our problem here, so we'll type in equals confidence.norm, and since we want to know the 90% confidence level, to find the alpha, it's 1 minus 90%, or 1 minus 0.9, so the alpha is 0.10, comma, the standard deviation was 5 hours, and our sample size was 64 students. We'll close the parentheses, hit enter, and if I round out my number, we get the same answer as we did doing it by hand or with our calculator from the lecture. So the margin of error is 1.03. So our confidence interval estimate is 23 hours plus or minus a margin of error of 1.03. Now, what happens if we don't know the population standard deviation? This is what we saw in our Legoland example in the lecture. So the distribution of overtime hours per week for employees at Legoland is normally distributed. A random sample of 10 employees is selected, which produces a sample mean of 4.5 hours and a sample standard deviation of 1.3 hours. Using a 95% confidence level, what is the margin of error? So here, we will type in equals confidence. Recall that when we don't know the population standard deviation, we cannot use a z-value. Instead, we end up using a t-value. So that's why we use .t here. Do parentheses. Our alpha is just 1 minus our confidence level. So 1 minus 0.95 gives us 0.05 for our alpha. The standard deviation was 1.3, and our sample size was 10. So when I close the parentheses there and hit enter, I get, and I'm going to go ahead and round this, 0.93 as our margin of error for the Legoland problem. In other words, our confidence interval estimate for the Legoland problem was a sample mean of 4.5 hours plus or minus 0.93 hours. The textbook also had some formulas on how to use Excel to find our critical z-values and critical t-values. While the lecture previously showed you how to do it using Appendix F, you can also use Excel. So for instance, if we were to use our Maricosta College student workers example, and we wanted to know the critical z-value for a 95% confidence level, you could just use the table I provided in the lecture with the most commonly used confidence levels, or you can use Excel. So here is the formula on the left to use Excel. We'll type in equals ABS, or absolute, because we're looking for the absolute critical z-value. If you don't do this, then your answer will be a negative z-value, which in Excel, it's because we always read starting from left to right, and the left side is negative. We'll go ahead and do parentheses, and then type in norm.s.inv, parentheses, another parentheses, because we're working with some pieces. We'll do 1 minus our 0.95 confidence level. Or you could have just subtracted that in your head and typed 0.05. And then divide by 2. Because recall when you look at the curve and we have our confidence interval estimate, we have 2 tails on either side of the curve that are outside of our confidence level. So that's why we divide by 2 in order to get the 2 tails. I'll go ahead and close my parentheses and then hit enter. Now, before I even hit enter though, I do want to highlight that you want to be careful with the parentheses, because if you miss one, Excel doesn't like it and it might not give you an answer. So if I hit enter, I can see that my z-value at 95% is 1.96, which we knew because I provided a useful table which had the most commonly used confidence levels. And if you'll notice, if you go over to Appendix F, and if you scroll down to the bottom where there is the infinity sign, you'll see here the z-values at the different confidence levels, because the infinity row here reflects where the t distribution meets the standard normal distribution. So here's our 1.96 right here, based on our 95% confidence interval if I looked at the confidence level up here. Let's do one more. Say, what is the critical value for a 99% confidence interval? Again, this is just for practice. We'll do equals ABS for absolute value, so it gets rid of any negatives. We'll type in norm.s.inv, parentheses, parentheses, 1 minus, in this case we wanted 99, so we'll do 0.99, close that parentheses, divide by 2, because we have two tails, and then close our parentheses, and we get 2.5758. Again, this should match what we had in my commonly shown confidence levels table. And if we look over in the Appendix F at the 99% confidence level up at the top and go all the way down to the infinity row at the bottom, you should see the same number as well. Where Excel comes in handy, especially, is if the confidence level asked in our homework problem is not one of the commonly used ones. Say it asks for a 93% confidence level, or 92, or 89. I would recommend using Excel to find the specific critical z-value in that instance, because our appendix does not give every possible confidence level there is, just the common ones. Now, just below here are the formulas if we are looking for a critical t-value. Recall that we look for t-values when we don't know the population standard deviation, just like we saw in our Legoland example. So for instance, what is the critical t-value for a 95% confidence level? So here's the formula to find a critical t-value, where t reminds you that, hey, this is a t-value, and 2t because there's two tails. Then in parentheses, as you type it, it'll show the word probability and the word degrees of freedom, where probability simply means 1 minus our confidence level, which is the same thing as we saw in the earlier formulas we called alpha. Not sure why Excel changes the language. This could have said alpha and it would mean the same thing, which is 1 minus the confidence level. And as you recall from the textbook in the lecture, the degrees of freedom is simply our sample size minus 1. So let's practice using our Legoland example. So here, if we wanted to know a 95% confidence level for the Legoland story, we do equals t.inv.2t parentheses, and our probability, again, is just 1 minus the confidence level, so 1 minus 0.95. Or you could have just subtracted it in your head and typed 0.05. Then type in comma. And our degrees of freedom in that problem, recall, was n equals 10 employees. So 10 minus 1 equals 9. So I'll type in 9. And then close my parentheses and hit enter. So my critical t-value is 2.2622, which is the same as we saw in the lecture video when we use Appendix F. So real quick, I'm going to scroll here to the right. Here I've got my Appendix F. I'm looking at a 95% confidence level, and I'm going to look for my degrees of freedom of 9, and here is the 2.2622. So you can either use Appendix F, or you can use Excel to find a critical t-value. We'll practice one more. What if in the Legoland problem, management decided that we wanted to use a 99% confidence level instead of a 95% confidence level? So here I'll type in equals t.inv.2t parentheses. My confidence level is 99%, so my probability, or my alpha, is 1 minus 0.99, or you could have just typed in 0.01, and then we'll type in comma, and our degrees of freedom, same story, same 10 employees, so n minus 1 is 10 minus 1, so we'll type in the degrees of freedom at 9, close my parentheses and hit enter, and my critical t-value will be 3.2498. If you have any questions, just let me know.